Okay, in this video, I'm going to show 3 examples of implicit differentiation. So if you know how to do the simplest ones, then just fast forward till the ones where you might have to do some factoring. And then finally, there's one where you're going to have to use the product rule. So you kind of be the judge what you need. So for this first one, implicit differentiation, we take the derivative of each term. So this 3 comes down in front, so this becomes 6x squared plus, here's a y, this becomes 6y squared. We tack on dy dx. The derivative of a constant is 0. Now we want to get the dy dx by itself, so we're first going to subtract the 6x squared. So then we're going to have 6y squared dy dx is equal to negative 6x squared. And finally, we're going to cancel the 6y squared. So dy dx is equal to negative x over y. Just like that. All right, I'm going to cover this up. This next one, it looks like there'll just possibly be some factoring involved. So we're going to take the derivative of the left side. So that would be 4x is equal, this is going to be negative 4y dy dx minus 15y squared dy dx, and the derivative of a constant is 0, so I'm not going to write it. Now these both have a dy dx in common, so I'm going to, and they both have a negative sign, so nope, I'm going to leave it just like this. I'm going to factor out dy dx. I'm not going to factor out the negative. And then that would leave, so if dy dx divide by that cancels, leaving negative 4. That cancels, leaving negative 15y squared. And then these two things, dy dx and this expression, is attached by multiplication. So we can divide both sides by negative 4, subtract 15y squared, and then dy dx. Now, since these are both negative, what is this positive up here divided by this negative? So it's probably a good idea to practice putting the negative sign in front, only in the situation where this is both negative and this is positive. Then you can write 4x over 4 plus 15y squared, or put the 15y squared first. All right, so that's it for that one. And then, okay, this one's a little bit more complex. The derivative of 2x is 2. The derivative of negative 2y is negative 2, but because it's the derivative of y, we're going to tack on dy dx. The derivative of this constant is 0, so I'm going to not worry about that. Now I'm going to switch to black because now we're going to take on this. Notice there is a product rule right there. So we have to remember the product rule. F times g prime plus g times f prime. The f in this case is negative 5x. So the derivative of f is negative 5. The g in this case is y cubed. The derivative of g is 3y squared, but it's the derivative of y, so tack on dy dx. So let's go ahead and get started. So I'm going to, there's a subtract sign right there. In fact, I'm going to change this because I'm going to leave the subtract sign on the outside, and I'm just going to put that whole thing in a bracket. So it's f, which is 5x, times the derivative of g, which is 3y squared dy dx, plus g, which is y cubed, times the derivative of f. And I guess I didn't need that bracket to be that far out there. All right, so now I'm going to simplify this before I do anything else. So we have subtract this phrase right here. Well, 5 times 3 is 15. So 15xy squared dy dx plus 5y cubed. Now I want to keep the dy dx's on the same side, so I'm going to subtract this 5y cubed. So now we have 2 subtract 5y cubed. And then on the right side, I'm going to factor out the dy dx, because they share that in common. Then in parentheses, I have negative 2 subtract 15xy squared. And now this is attached by multiplication. I'm going to divide both sides. I still don't like leaving the negative sign down there, and so I would do this. This positive divided by negative, I would turn this to negative, this to positive, and then both of those. I would change the sign of all of them. So our final answer would be dy dx is equal to, I'm going to rewrite that, 5y cubed subtract 2 all over 2 plus 15xy squared. And no, you can't. Remember, one of the easiest mistakes is to think you can cancel. You can't just cancel, because those things are not just factors. Remember, this is an expression and this is an expression. In order to cancel, all 4 terms would have to have something in common before you could cancel. All right, that's it for this one.